We are recording. Okay, so y'all, 6.2, still talking about confidence intervals for the mean, for the population mean, okay? Excuse me. The difference, though, was that in 6.1, we knew the population standard deviation. In 6.2, we're not going to know the population standard deviation. We're going to know the sample standard deviation. There's going to be one small change that we're going to do, but the process, y'all, will still be the same. Okay, so when we don't know the population standard deviation, right? So let me do this. When we do not know this, so look, y'all, right here, we're not going to know what sigma is, okay? But we're going to know in our calculators, y'all, our calculators will use it like this. They'll have a little S with an X. We're going to know that number, okay? They'll give us, we'll have the sample standard deviation, okay? So, y'all, as we go, like when we finish up chapter 6 and we go into chapter 7, we're going to talk about a t distribution. A t distribution, y'all, it works very similar to the normal curve with one small change. When we were doing our stuff in 5.4 right before we left for spring break, we were doing that formula where we had to take the standard deviation divided by the square root of n. We're going to be doing the same thing, except we would do that with the sample standard deviation. Okay, we'll take a look at that stuff later in chapter 7. But a t-score, y'all, is going to be very similar to a z-score. Okay, so what are some properties of the t distribution? The mean, median, and the mode are going to be 0. The t distribution is bell-shaped. So look, this is what the t distribution kind of looks like. Okay, it's still bell-shaped, still symmetric about the mean. All the area under that curve, y'all, is still 1 or 100%. Okay, nothing any different. The only thing is that the tails in the t distribution are a little thicker. Sometimes they're a little bit higher over here. Okay, it doesn't kind of taper down as fast, but it still tapers down, just not as quickly as the z one did. Okay. Now, there's one difference in the t distribution. And there's this idea, y'all, that we're going to call the degrees of freedom. Okay. So I'm going to explain to you guys what the degrees of freedom is in the t distribution. So it says the degrees of freedom are the number of free choices left after a sample statistic, like our sample mean is calculated. When we use a t distribution for the population mean, the degrees of freedom is 1 less than the sample size. So my degrees of freedom, y'all, is going to be n minus 1. Okay, I'm going to explain that concept to you guys right here. So look, y'all, I wrote a little paragraph here that talks about the degrees of freedom. And it says, suppose that there's an equal number of chairs in the classroom as there are students. So 25 chairs, 25 people. It says each of the first 424 students in that classroom has a choice to where he or she is going to sit, but there is no freedom of choice for the 25th student. Y'all, I'm going to make this even easier. Suppose we have 5 students and we have 5 seats. Okay, so those are my seats. Suppose we have students, I'm going to keep this real simple, y'all. A, B, C, D, and E. Okay, now suppose A is the first student who walks into that room. Student A has a choice on where they want to sit. They have 5 places that they can choose from. I'm going to make this up. Suppose student A goes there. Okay. Now look, y'all, student B walks in. They have a choice on where they get to sit. They get to sit anywhere they want. Well, maybe not here, but they still have a choice. So suppose B goes over there. Okay. It doesn't matter where they sit, but they have choices, right? Now, let's do this. Suppose student C comes in. Student C still has choices, right? There's still 3 empty seats. Suppose student C goes there. And then student D walks in. Does student D have any choices on where they can sit? They still got some choices, okay? Y'all, who does not have a choice on where they can sit? E, right? E's got to go there. So how many people had choices? 4 of them, right? So if my sample size was 5, then 1 less. 4 of them actually had a place on where they could choose to sit, right? That's what we mean by the idea of degrees of freedom, okay? That's going to be the only slight difference, okay? Now, when we go to the idea of how do we find what we're going to call t-scores, y'all, we're going to do something we call t-scores. And it says, find the critical value TC for a 90% confidence level when the sample size is 22. Okay, y'all, I'm going to show you two ways of approaching this. Y'all, I'm still going to make a bell-shaped curve. Okay, boom, here's my bell-shaped curve. Y'all, remember our confidence level here is 90%? Okay, so remember what that means, y'all. That means that the area, my friends, between those two green lines is 0.90, right? So remember, y'all, if we wanted to find the area, say over here to the left or over there to the right, we would have to figure out how much area is left. So we could say, look, 1 minus 0.90, 0.10, and then if we divide that number by 2, wouldn't that be 0.05? So look, y'all, the area to the left over there and the area to the left over there would be 0.05. So y'all, just like we did on Tuesday, we're going to have two values, right? And if you remember on Tuesday, y'all, we would first find this guy because then it was real easy for us to find that guy, right? We would just say, look, it's going to be the positive one. Now, when we're going to do this here, the first thing I'm going to do, y'all, my sample size is 22. So my N is 22, but my friends, my degrees freedom is going to be one less. 22 minus 1, 21, okay? Now, the reason I'm telling you this, y'all, I'm going to show you two ways that we can do this, okay? One way is we can use a table. I'm going to just show you what the table is so you can see like the table does it, but I'm going to show you on the calculator because I think most of us are pretty much savvy on our calculator. Yo, if you go to your notes and you scroll all the way down or you look at the last page of your notes, there should be some kind of a table like this, okay? So here is my table. It's the last page in the notes that I gave you. Look, y'all, I'm going to look at my level of confidence. My level of confidence, we said we were looking at 90%, right? And then our degrees freedom, y'all, we said was what, 21? So look, y'all, if I look right here, my T value, my friends, would be 1.721. Does that make sense on how I did that using my table? So look, y'all, again, I'm just going to scroll back up here to where we was. A little higher. Oh, maybe not that high. Oh, maybe a little lower. Come on now. Boom. A little lower, a little lower, a little lower, a little lower. Oh, come on. Okay, so here we go. 90%, right? Degrees freedom 21. Again, one last time, y'all, just again to show you right here. Sorry. Oh, here we go. 90%, right? It's the second column, degrees freedom 21, 1.721. Okay, that's how I do it using my table. Okay, now let me show you the easy breezy cover go away of doing this on your calculator, okay? So I'm just gonna write down the answers so that we don't forget. Okay. 1.721. All right, now, y'all, on your calculator, I'm gonna show you guys something. Let me get this guy going. Okay, let's turn it on, let's clear it. Guys, on your calculator, you're gonna hit second vars. Now, I'm going to tell you right now, y'all, my calculator, the software that I have on my computer, it's old. So my calculator doesn't have it. But on yours, let me ask you a question, guys. Those of you who have the TI-84 or something like that, right under your inverse norm, is there one that says inverse T? Okay, do me a favor, guys. Go ahead and click on inverse T, okay? Now, remember, y'all, the calculator is always going to tell me my area to the left. What is the area to the left over here? What is this area? 0.05. Okay, so guys, you're going to type in 0.05. And then after that, you're going to enter in the degrees freedom. When you enter the degrees freedom, you're going to get 21. Y'all, are you coming up with something that looks something like negative 1.721 if you go to 3 decimal places? Are you guys getting that? Okay. So y'all, again, I'm showing you this, y'all. My calculator, again, it's old. I know my calculator here says it's the TI-84. The software, y'all, for this one is actually the TI-83. And so it doesn't have it on there. And there's a little program I can type in the calculator. And y'all, back in 2019, when I did that, I would have to type it in every time because it wouldn't save it. But just to give you a heads up, this was the other thing I did, y'all. I just went to Google and I typed in inverse T distribution calculator. And let me tell you the one that I was using, or the one that I found that was kind of neat. No, not that one. That one kind of sucked. Let's see. What about this one, maybe? No, not that guy either. There was another one, y'all. I'm trying to see if I can find it. No, that's not the one I wanted. I had it up here. Oh, man. What did I do with it? Statology? No, that's still not the one that I wanted. Produce? Yes. Okay. So look, y'all, I'm going to go like this. My degrees freedom, we said it was 21. My area was 0.05. And y'all, we were looking the area below that, right? Because remember, my calculator is always going to tell me the area to the left, which means below. Isn't that negative 1.721? Again, if I go to 3 decimal places. So that's what I used. And y'all, what I'm going to do here, I'm going to copy this link. And let me see, sorry. I am going to drop it in the Pronto chat so that if anybody wants to use that, you'll have access to that. Okay, y'all? And again, I just did it was just like a quick Google search, y'all. But that's what I'm going to do, y'all, because my calculator doesn't have that. But you guys are going to go inverse T, area to the left, and then degrees freedom, okay? All right. So now that we know how to do degrees freedom, or how to find the t-score, the t-value, y'all, we're going to do constructing confidence intervals and t-distributions. Okay, so just like we did the other day, y'all, we were finding our error, okay? There's a formula for my error here, okay? Yes?
Sorry to interrupt, sir. So the answer, we just write it as -1.
But it's going to be positive, right? Because we're always looking for the positive one, right? So when I do it on my calculator, I want you to think about this. Guys, I'm going to show you guys something real quick. Y'all, remember that my calculator always is going to give me the t-score or the z-score when I'm doing the area to the left, right? Okay, so once you find this guy, it's really easy to find that guy because you just make them positive, right? Okay, now let me show you one last thing before we go on. Guys, I want you all to look up here. If I were to color all of this, what would you say the area that in yellow would be? All the area in yellow. So we know the area in the middle is what, 0.90?
Wouldn't that be 1.72?
But hold on. But I want you to look here. Would y'all agree that the area in the middle between these two is 0.90? And then that's 0.05. So wouldn't that area be 0.95? Okay. Now look, y'all, I'm going to come back to my thing right here. Instead of me doing 0.05, let me do this. Let's go 95. Boom. Didn't we just get the positive answer?
Yeah.
That's another way you can do it. I think doing the negative one, to me, it's just easier, and then change your sign. But you can do it like that too, right? And now we found that guy right there. So whereas before we were finding the negative value and then changing the sign, you can actually find the positive value you want to as well. Good questions, y'all. Good questions. Okie dokie, artichoke. So look, let's see if we can find our margin of error. Okay. So again, y'all, we're going to do this just like we did on Tuesday. On Tuesday, because we knew our population standard deviation, we used the sigma. But now, y'all, we're going to have our sample standard deviation. So the first thing we need to do, we need to find our T of C score. Okay. So look, y'all, first thing I'm going to do, I'm going to draw a picture. The same sort of pictures, y'all, that we drew on Tuesday. Okay. So look, y'all, the area in the middle here is 0.99, right? So my friends, if I want to find the area on the left, I know that this area here and that area there is 0.01, but I got to take that number, y'all, and I got to divide it by 2. So that's telling me that this area over here, y'all, 0.005, right? Because we took 0.01, we divided it by 2. If you're uncertain, we can do that. Boom, 0.005, right? Okay, so now, y'all, remember, in order for me to find my TC value, we're going to go on our calculator, inverse T. We're going to type in 0.005. And then remember, the next number here, y'all, is going to be my degrees freedom. My degrees of freedom, y'all, is always going to be 1 smaller than my N. So if my N is 20, then my degrees freedom, y'all, should be 19. Okay, guys, I'm going to do this on this guy right here. We said 0.005. Degrees freedom was 19. Let's recalculate it. Are you coming up with 2.86?
Yes.
2.861? Yo, for whatever reason, and I honestly, I don't know, but I'm going to find out and I'll tell you guys on Tuesday. But what do we say? 861? Yeah. Okay. 2.861. Yo, for whatever reason, with the T values, we normally go to 3 decimal places. I'm not certain why, but it's always been going to 3 decimal places. I'll find out, guys, and I'll tell you guys, because I knew before, but I forgot off the top of my head. Okay, so now let's see if we can find our error. We're going to take the value of TC. My friends, we just found that to be 1. Okay, then we're going to multiply that by our sample standard deviation. Y'all, my sample standard deviation is 6. And then we're going to divide that by the square root of 20. Okay.
So this time we do use 20, we wouldn't use 19.
That's right. That's right. The only time we're using the 19 is when we're trying to find that T value, right? So look, y'all, 2.861 times 6 divided by square root of 20. Oops. Oh, man, I did something wrong here. Okay. 2.861 times 6 divided by square root 20. There we go. 3.83, right? Or 2. Let's go ahead and go 3 decimal places, y'all. 3.83, what? 8 or 9? 8, right? Okay, so error is going to be 3.838. Boom. And we found our error.
And that would be this would be the 3.838, that's your TC? Or
That's the error, right? That's the maximum error. So
that's
what
your E.
that's right. So what we know, y'all, is that the population standard the population mean, y'all, when there's a 99% chance that it's going to be between these values, right? Where the error is 3.838. We don't know what the sample mean is, but we know that the error isn't going to be more than 3.838. Okay. All right, y'all, I'm going to skip this one. It's going to do the same way we did on Tuesday. I'm going to skip that one and we'll come back and take a look at it in a minute. Okay. So a couple of things I'm going to show you guys how to do here. I'm going to show you guys how to find our confidence interval. I'm going to show you 2 ways, y'all. We're going to first do it by hand, and then we're going to do it using the calculator, okay? So I want you to notice what they're telling me here. They're asking me to construct a confidence interval for the population mean. Y'all, I cannot emphasize this enough. We're always going to be talking about our population mean, okay? So first thing is we want a 98% confidence level. So my friends, I'm going to draw my normal curve, right? The area in the middle is 0.98. So y'all, if we go 1 minus 0.98, we should have 0.02 left to go in each of those spots. So wouldn't this spot here, y'all, be 0.01? If it's 0.02, because we got to divide it in half. So each of them goes into those spots, right? So again, y'all, how do we find our TC value? We're going to go inverse T, 0.01. And then remember, y'all, we got to do our degrees freedom. My degrees freedom, y'all, is always going to be 1 smaller than my N. So that should be a 14. So look, y'all, if I come back here, we said that was 1. This was 14. Oops. 14. And we calculate, oh wait, not 1, sorry, 0.01. There we go. We calculate it. Guys, is anybody coming up with 2.624 for your T if you do this using the inverse T? Okay. There you go. So look, y'all, we found our TC value, right? Boom. We found our TC value. Okay. Now, look, y'all, we're gonna find our error now. Okay. So look, step number 1, we found the TC value. Step number 2, y'all, we're gonna find our error. The error says we're gonna use this formula. We're gonna take that TC value, we're going to multiply it by S and divide it by the square root of N. So I'm going to take 2.624, okay? We're going to multiply it by S, which in this case, y'all, is a 0.56. And then we're going to divide that by 15, okay? So 2.624 times 0.56 divided by the square root of, what do we say, 15? Okay. And y'all, I'm going to go ahead and go to 3 decimal places here. Is anybody coming up with 0.379?
Yes, sir.
All right,
Oh,
awesome.
actually, no. I'm coming out with 3.829.
Did you take 2.624 times 0.56
Uh-huh.
divided by the square root of 15?
Yes, sir, exactly. You see it?
But you didn't. Okay, but you have to divide it by the square root of 15. You just did the square root of 15.
Oh,
Okay. All right. Is anybody else getting 0.379? Are we all doing okay so far? All right. So look, y'all, we found our error, right? Okay. Now, how do we find our confidence interval? Step number 3. Look, y'all, we're going to do this. We're going to take X bar minus our error and X bar plus our error. So look, y'all, my X bar in this case was 12.6. I'm going to zoom out, y'all, just so everybody can see this.
that would be
So 12.6 minus 0.379, 12.6. Oops, sorry. Wrote it wrong the other way, guys. My bad. This should be plus, and this one should be minus. Sorry. Plus, and this one over here, minus. My bad. 0.379. Okay. So let's try that. 12.6 plus 0.379. Y'all, I'm coming up with 12.979 for my first number. And then my second one, 12.6 minus 0.379, 12.221. There we go. And we found our confidence interval, right? So all we did, y'all, was we took our average, right? We took our average and we added the error, and we took our average and we subtracted the error, okay? Now, y'all, one thing that we can do here in doing a problem like this, we can also use our calculator. Let me do this, guys. Let me clear everything. I'm going to hit stat. I'm going to go over to tests. And I should have a T interval test. Boom, there it is. Excuse me. There it is, y'all. Number 8, T interval. So I'm going to click on that. We're going to go with not data, but we're going to go with stats. Okay. So I got to go to stats and then I got to hit enter. And let's see. Y'all, all I'm going to do here is start entering my numbers in. My X bar, in this case, y'all, was 12.6. Okay. Our sample standard deviation, y'all, was a 0.56. Okay. Our N in this case, my friends, was a 15. Okay. And our confidence level, I believe we said 0.98, right? Because it was a 98% confidence level. And I'm going to hit calculate, and I'm going to let it do its thing. And look, my friends, 12.21. Oh, I guess I did have it right the first time. It should have been minus, and then because I have 12.21, I just got them the other way around.
Man, so this is good. This is like a good way to check your answer.
Right? 12.21. Sorry, guys. Oh, you know what? It was right. Sorry. Sorry, y'all. Sorry, guys. Had a little brain fart today. Apologies. Boom. We had it right the first time. This was minus. This was plus. So we'll just switch those two folks around. Okay. 12.221. 12. I already forgot. 979. There we go. Okay. Sorry, y'all. We did have it right. So, y'all, The reason why I wanted to show you this process is I think sometimes doing this, okay, we get the answer, but what does that mean? Okay, so just to give you an idea now, what does this mean? There is a 98% probability that our population average falls between those two numbers. That's really what a confidence interval tells me, okay? That we are 98% certain that our population average will fall between those two numbers based on our sample mean being 12.6 out of 15 samples or whatever it happened to be, okay? So look, let's try this one, guys. We're going to use the calculator for this, and we're going to see if we can't figure it out. Okie dokie, artichokes. So first thing I'm going to do here, y'all, it says, look, in a random sample of 19 people. Okay, I'm going to start writing a couple of things down, y'all. First thing that tells me, my N, y'all, is 19. Okay. Second thing, it says the mean commute time to work was 30.8 minutes. My X bar, my friends, is 30.8.
So, sir, X bar is always like the U one.
It's kind of like the mu, right? It's kind of like it's the average, but it's the average for the sample. Very good. The sample standard deviation, y'all, was 7.3. So my S here, y'all, 7.3. Okay. And then right here, guys, look what we're going to do. We're going to make a 99% confidence interval. Okay. So y'all, I'm going to just do this. My confidence level, 0.99. I don't necessarily need to draw a picture here, y'all, because I'm going to use my calculator for this business. Okay. So look, let's do this, guys. Let's go back to stat. Let's go over to test. Let's scroll down until we hit our T interval. Boom, right there. And we're going to stick with doing the stats, y'all. So go ahead and make sure you're on stats. Okay, my X bar, y'all, in this case, we had 30.8. Okay. My sample standard deviation, my friends, was 7.3. Okay. My N in this case, y'all, was 19. And our confidence level in this case, y'all, is a 0.99. I'm going to go ahead and go down to calculate. Boom. And I'm going to give it a minute because, again, my calculator is old. All right, y'all, let me see what they want me to round here to. They're asking us just to go to one decimal place. Let me ask you guys a question. 25.9 or 26? What do you guys think? 26, very good. 26, right? Boom. What about the next number? 35.6, 35.7? What do you guys think? Anybody got a clue? 35.6, right? Awesome.
Sir, you used the number 7 or number 8 on
The T interval.
the T interval?
The T interval, right? So again, look, let's come back here, go to stat, go to tests, go down to T interval.
Oh, 8.
There you go. And enter your info in, right? Guys, does anybody got any questions? Are we doing okay with this? Just want to make sure you guys are good.
I used number 7. And I was like, I mean, it almost gave me exactly what you have. But
Yeah.
It's a little different.
It's a little different, right?
Yes.
Okay, now, y'all, we want to find the margin of error, okay? Let me show you the easy breezy cover go way, y'all, that we can find the margin of error. There's two ways we can do it, y'all. First way, take the bigger of the two numbers, 35.6, and subtract off our sample average, okay? So look, y'all, I'm going to grab my calculator. I'm going to say, what's 35.6 minus 30.8? And y'all, I'm coming up with 4.8. That is my margin of error. Y'all, the other way you could do it, we could take 30.8. I'm just trying to get some room here, 30.8. And we could subtract off the smaller value, which was 26. And you still get 4.8, right? Because remember, it's 4.8 on either side of that sample mean. Okay.
So, okay.
Right. So remember, guys, remember how we did this problem over here? Remember how we found when we had found the error, right? We took X bar minus the error, X bar plus the error. That's really what we're doing to find that error, right? We're saying, let's do this. Let's take either the big number minus the sample to find the 4.8, or Let's take this number minus that one. You're still going to get 4.8, right? Okay, now, guys, one thing I wanted to talk about, like I said, what we're talking about in chapter 6 is population means. So y'all, the first thing I'm going to do is I'm going to look through my choices when I get to this last part. Which of those up there, my choices A, B, C, or D, uses the term population mean? Which one do you guys think says population mean up here? C. Boom. With a 99% confidence, it can be said that the population mean commute time is between those bounds. Y'all, chapter 6 always talks about population mean. So one thing that, again, when I've taught this class before, students say, sir, but like, why did they put all those other things in there? Don't worry about it. Look for the word population mean, right? If you look for population, you'll be able to figure it out. Okay. So, y'all, I got another question here. Now, it says the state score or state test scores for 12 randomly selected high school seniors are shown on the right. Complete parts A, B, and C. Look at the first thing they want us to do. They want us to find the sample mean. Y'all, you already know what we're going to do, right? We're going to clear this thing out. We're going to go to stat. We're going to go to edit. If you need to clear your list, y'all, just go up to the top to where your L1 is highlighted. Hit the button that says clear, hit enter, and it should clear everything out, okay? Y'all, I'm going to go left to right. So I'm going to go 1429, and then I'm going to go 1221, and then I'm going to go 989, and then I'm going to go 699, and then 727, and then 839, 729, 740, 541, 624, 1443, and 945. Okay. And y'all, how you enter them in, it doesn't really matter. I'm going to tell you real honest, guys. The other day I was doing this problem because I go through my stuff before I come here, and I was getting the wrong answer. And what I did was I entered this column in twice. That's why I missed it. That's what I was like, man. So it's easy for me to go left to right. Okay. Now that we do that, y'all, we're going to go to stat. We're going to go to calculate. We're going to calculate our one variable stats for our list one. So make sure that your list one is the one that's listed, if that's what you put them in. Okay. Did anybody get the same sample average? 910.5? Anybody get that same number? 910.5? Okay, awesome. That is our sample mean.
Do you put all those numbers in list one, sir?
I put them all in my list one, yeah. They got to go in the same list. It doesn't matter what list you put them in. Just make sure when you do your one variable stats, you're doing it for that list, right? Don't do it for another list. Okay, now my sample standard deviation. Y'all, my sample standard deviation, it's that SX number. Look what they're asking me to do. They're asking me to go to one decimal place. Y'all, would you say 304.5 or 304.6? 0.6, right? Awesome. 304.6. Boom, there you go. Okay. Now, let me show you the next part, y'all. When we're going to do our 95% confidence level, this is what we're going to do, y'all. We're going to come back to stat. We're going to go over to tests like we did before. We are going to scroll down to our T interval. We're going to hit enter. But y'all, instead of us going on stats, we're going to go on data. Boom, there we go. Let me hit that. And I want to make sure, y'all, that it's my list one. Okay, that it is my list one. What confidence level are we looking at here, y'all? 95%? So look, y'all, all I'm going to do is come down here. Oops, sorry. And change that because by default, at least on my calculator, I had 99. I'm going to make it 95. So again, y'all, just to give you a heads up, I went back to my test, T interval. I went to data. Make sure that your list is L1. Frequency is probably going to say the number 1. Make your confidence level 95. Go ahead and go to calculate. Give it a minute. Okay, so look, y'all, we're going to do this. Let's see, what are our numbers? They want me to go to one decimal place. What do you think, y'all? 716.9 or 717? 717. all the way to what, 1104? Boom. And we found our confidence interval, right?
Just gotta remember.
You got to remember the steps, y'all. You got to remember the steps. I'll put it this way, y'all. The way, and actually in the next question, we're going to figure out, how do I know when I'm doing Z interval? How do I know when I'm doing T interval? Okay. Z interval, you're given sigma. You're given the population standard deviation. T interval, you're given the sample standard deviation. That's the only thing you're going to have to know. Okay. So look, y'all, let's come back over here. Here we go. How do we know to use the standard normal distribution or the T distribution? Okay. Y'all, if we have the population standard deviation, this one, then this is the guy that we use. Okay. If we don't know it and we only know our SX or our S, the reason I put the little X, y'all, is because when we do this on the calculator, see how it has S with the X? That's why I write it as SX, okay? Because my calculator tells me that. If the only one I know is this guy, then I have to use the T distribution, okay? All right, so look, let's figure out this next two questions, guys, and then we'll go back and do that one that we had kind of skipped over. Okay, so look what it says. We randomly select 25 newly constructed homes. Okay, first thing I'm going to do, y'all, before I even keep reading, y'all agree my N is 25? Okay. Second part, sample mean construction cost is 181,000. My X bar, y'all, 181. Okay. All righty. Look what it tells me right here. Population standard deviation is 28,000. My friends, that is my sigma. Okay. Okay. Now the question says, should we use the normal distribution or should we use the T distribution? Y'all, we're going to go with the normal. Why? Because that's the guy that we know. Okay.
So we would use the first one in red for that.
That's right. So look, what kind of a confidence level are we looking at here?
25.
Yes, my confidence level, y'all, 0.95. Okay. Y'all, we're going to use our Z interval test, okay? So look, let's clear everything out. Let's go to stat. Let's scroll over to tests. We're going to do number 7. We're going to do the Z interval, okay? Y'all, again, on my calculator right now, it says data. I don't want to go to data. I want to go to stats, okay? I'm going to hit enter. Okay, let's start entering some info in. Sigma. We said in this case, y'all, sigma was what, 28,000? Okay, I'm going to type that in. 28,123. Okay. My X bar, y'all, we had 181,000. Remember, we're talking about the price of houses, right? You're not going to get a house for whatever number we had there, right? $8,000, something like that. My N was 25 because we're looking at 25 houses here. Our confidence level, 0.95, we are already there. Okay. Let's calculate this guy. All righty. Here we go. So y'all, I'm going to do this. Boom, boom. 170,024 all the way to 191,976. Okay. So what we're saying, y'all, again, just to make sure everybody's clear, we're saying that if we took all the houses, okay, and we found the average price of all the houses, we're 95% sure that they're going to be between those two numbers. That make sense? All right, good. All right. So look, y'all, we got just 2 more problems. This one, and then we'll go back and do that other one that we had skipped a little while ago. All right. Let's see. We randomly select 18 adult male athletes. Okay, look, y'all, my N, 18. We measure the heart rate of each. The resting heart rate is 64 beats a minute. Okay. Right here, my friends, I want you to look at that word right here, sample. That's my SX. Okay. Okay, now we're going to make a 90% confidence interval. Okay. Y'all, we're going to use the T distribution because that is the guy we know. Alrighty, y'all. We're going to go to our calculator again. Let's clear this guy out. We're going to go back to stat. We're going to go to test, but we're going to now scroll down to number 8, T interval. Okay, we're going to use stats, y'all. We're going to use stats because that's what we got. Okay, let's see. What do we know? What is my X bar? 64. Why? Because we're talking about our heart rate. What is my SX? Oh, it's 2.5. Okay. How many athletes did we have here? 18, right? And our confidence level, my friends, is 0.90. Oh, sorry. Thank you for telling me. Thank you. My bad. 2.5. There we go. Okay, 0.90. I think 0.9 is fine too. Boom. Let's go down to calculate. Yeah. And I don't know about you guys, but on mine, the T interval takes a little while to do. Okay. So, y'all, let's go ahead and go to, let's just go to 1 decimal place. So, guys, if we're going to go 1 decimal place, would you guys say 62.9 or 63? 63, right? Boom, 63 all the way to, would you say 65.1 or would you say 65.0? 65 point, which one? 0 or 1? 0, right? Good. Okay. So y'all, again, what are we saying here? If we were to take, right, the resting heart rate of any adult athlete, it's got to be a male because I think they're adult male athletes. And we found the population average. There's a 95 or 90% chance that the resting heart rate is between those two numbers. Okay. All right. So guys, let me scroll back and let's do this last problem that we hadn't done yet, which was, boom, this guy right there. Okay. So y'all, if we want to find our first sample mean, X bar, what we're going to do is we're going to add those two numbers together and we're going to divide by 2. So we got 14.7 plus 22.5. Let's divide it by 2, 18.6. There's my sample mean. Okay. Right? That's my sample mean. That's the number that's in the middle, right? My sample mean, guys, always going to be directly in the middle. That's why we added them together and divided by 2.
Can we say call it like X bar? Or
not? Look. X bar, right? Okay, now we want to find our error. Remember the way we find our error, y'all? You can take the big one minus 18.6. 22.5 minus 18.6, 3.9. Or you could have said 18.6 minus 14.7. You still would have got 3.9. Yes. Oh, question? Or are you just stretching? Okay. And there you go. What do you guys think? Confidence intervals, pretty easy to understand. Not too difficult, y'all. Not too difficult. Y'all, just real quick, like, this might be, honestly, I'm thinking about it right now. This might be before your time. It might have been about the time you guys were born. Has anybody ever heard of this guy named Lance Armstrong? He was a cyclist. Okay, so he was a cyclist. He won Tour de France. What do you know about him? There's a documentary on Netflix. Steroids, right? He was like this athlete, and everybody was like impressed with how well he did. And then they found out he was taking performance-enhancing drugs, right? Doing all this stuff that nobody's going to tell you that it's necessarily wrong to do. But if you're going to compete in these things, you're supposed to be clean, right? He had cancer at one time. But y'all, when I lived in Austin, there was this gym that I started going to for a little while. And he was one of the co-owners, and it had his stats there. His resting heart rate, y'all, was something like 34 beats a minute, because he was so well. What's the easiest way to describe it? Like his body was so conditioned that his heart would go like this, boom, boom, and that blood just flew, boom, boom. You know what I mean? And right. So, guys, let me ask you a question. You ever walk up the stairs and you do 2 or 3 flights and you get there and right? Okay, Lance Armstrong, that never happened to Lance. You know what I mean? Because his body was so well conditioned. But also he did steroids and all that other stuff, right? But I remember that. And that always just like freaked me out. Like, dude, how does this guy, but what is he, at 4 o'clock in the morning, we're all there hugging our pillow with babas on it, right? You know what he's doing? He's out there riding his bike. You know what I'm saying? There's stuff like that. Anyway, just a little FYI. Guys, that is 6.2. That is it for us today, my friends. Let me come back over here. Let me stop recording it. Boom.